Okay, so when we're graphing radical functions, they're just going to be square root or cube root. And if there's not a number here with the radical, it's a 2, right? So what two numbers multiply to make inside? And so we're going to do this on Desmos and by hand. We're going to do both, which means for some of this, we're going to do what we didn't do previously, and we're going to actually convert the radical to a decimal. So you're going to need a calculator, probably an online calculator. Ow. I pulled like a tendon in my thumb or something. Don't know how. Now my thumb just hurts. So we're going to be making a table to do these, and then we're just going to be graphing the points as close as we can, because we're going to get some decimals that go on forever, and so we just need to get as close as we can to where they would be on the graph, and then we're going to check it with Desmos and talk about domain and range. Okay, so where did my... Yeah, there. So step 1 is just make a table. Table. Make a table. If this needs to be bigger, I can make it. I can zoom in. Just move the paper around. Okay, so we're going to make a table. The table is going to change a little bit depending on which one of these we're doing. Okay, previously I said when we make a table, you put 0 in the middle and you go to negatives and positives. For this, when we put negatives into a square root, we get imaginary numbers. So don't put negative numbers in there. So we're going to start at 0 and then just go up. 2, 3, 4, probably. So each of these is going to give a decimal, except for 0 and 4. When we make a table for the cube root, it can be negative. It can be negative. So we'll put 0 in the middle and do 5 numbers. -1, -2, -1, 0, 1, and 2. Okay, none of these numbers, except for 0, are going to cube root nicely. They're going to look kind of weird. Okay, so we'll do one of these at a time. I'm going to write all the steps over here, but we're only going to fill out one of these at a time. And then we'll graph it. Okay, so make a table. Evaluate the points. No negatives. Negatives for the square root. Now, this is a bit misleading because if we have like a minus, we're not going to just do the square root of x, right? We're going to multiply this, we're going to subtract it, we're going to move it around. But like if we had a minus or a plus inside this square root here, then that might change what our table, like the starting point of this is going to be. But the starting point is always going to be when this evaluates to be 0. We'll do some examples that might make a bit more sense. So that's step 1. We'll evaluate these in a second. Step 2 is just going to be graph the points. Plot the points. Graph and plot the points. So you'll need to make a graph. If you have graphing paper, this will be easier. I already kind of know what this looks like, so it makes it easier to know what the graph needs to look like, and we'll get there in a second when we actually graph it. But you need a graph. Sorry, I know my face is covering it up, but I just put another coordinate plane on the other side. I'll move it in a second. And then because this is a function, you're going to connect the points with the line, a curvy line. So we'll do that when we actually evaluate it, but I'm just going through the steps. So make a table, graph and plot the points, and then step three is something that you have done before, but we have skipped covering it for most of the things just due to time. But for this, I think it's the most obvious and actually useful. For other things, it's like, well, that's just domain and range. But for this, we want to talk about what is the domain and the range. And so I'm going to define those in a minute when we get to them, and I'll explain them more. But those are our 3 steps that we're going to do for almost all these graphing problems. Okay, so the homework, I'll probably give you like 4 of these. Or like, here's 4, pick 2 kind of thing. So you're going to make a table, plug in this stuff, calculate the values, and then graph them, and then the domain and range. Now, I know you can just plug the function into Desmos. I know you can do that. But we want to be exact and precise, and we just want to practice. You need to know how to plot a point and find what that point is. Because this is useful for any function. Any function, this is the process you use. Make a table, plot a point. Try to move that over because I know it doesn't line up always perfectly. And then make the graph. So table, graph. Always. So when we plug these things in, some of them are going to be really easy, especially for the square root ones. I guess this is red. That's fine. What's the square root of 0? Well, that one's easy. That's 0. Right, it's the square root of 0. 4 is also easy because this is just the square root of 4, which is 2. So we're going to have points at 0, 0, and 4, 2. The rest of these, actually 1 is also easy. Square root of 1 is 1. Okay, the rest of these are going to be decimals. Square root of 2 and the square root of 3. And I probably should have left more room here because we need a calculator to figure those out. Probably should have left more room, but it's okay. Okay, so square root of 2 and the square root of 3. Actually, these square roots are going to come up a lot. Square root of 2 and square root of 3. Those are very common square root numbers. I don't have them memorized. And so if we go to Desmos, here's Desmos. And we need the square root of 2. So that's 1.41 going on. We're not really going to be able to accurately put in the decimal places for beyond even 0.4. And so just knowing that it goes on forever and then it's pretty close to 1.4 is really good enough. Okay, so that's the square root of 2. And then we also need square root of 3. The way that I got this square root symbol is I just typed SQRT and then the number. Okay, that's how I got this first one. And the same thing for the square root of 3. So when we do cube root, we'll need to use our little function here to be able to put the 3 up there, but this is fine. So 1.41 and 1.73. If you have a calculator or your phone, you can use those to do this calculation too. You don't need to use Desmos. Okay. So we'll come back to Desmos here and plot the actual graph in a second, but now we have values for all of these. We have 0, 1, 1.4, 1.7, and 2. It's going up, but it's actually going up slow, or more slowly. as time goes on, right? From 0 to 1 is 1, but from 1 to 2 is only 0.4, and then it's only 0.3, and then 0.3. Like the difference is getting smaller. So our graph is going to kind of do this curved thing out to the right. Okay. So now we just need to plot those points. And I'm going to try to, really I should have just made the graph like an L here, right? Because there's no negative numbers. And there's no numbers over here. But I want it to look like this because we're going to talk about domain range. So plotting the points. 0, 0. I'm going to actually make this kind of large here. 1, 2, 3, 4. So I'll need to extend my line. And then we're only going to go up 2. So 1, 2. Okay, so 0, 0 is my first point, and then 1, 1 is my next point. And then I'm actually going to plot all the easy numbers first. 4, 2 is my last point. So you can tell it's going to make this kind of curved shape going to the right. Okay, and then 1 point, so we go to 2, and then it's at 1.41, which is a little less than 1.5. So like there, and then 1.7, like there. So our graph looks like this. Actually extend this if we want. Okay. So I'm actually going to put that into Desmos, but I'll leave it on the screen for a second, but I'm going to put it in Desmos. You don't need to do this. So hopefully we have time for a number of examples. Okay. So I'm going to leave that there, and then we're going to look at Desmos. I need to turn both of these off. So that should look like this thing. Am I on projector mode? I am. Cool. It should look like this thing. And we can check it. At 0, 0, there's a point. At 4, 2, there's a point. And then every time we have a perfect square number like 4 and 9, we're going to get an even number. So 9 gives us 3. 16 over here would give us 4. 16, 4, and so on. But everything else is going to be some sort of decimal point. Ooh, I did not mean to zoom in. Okay, so that's the square root function. Now, you have actually seen this curve before. Okay, you've seen this curve before, but not in this class, but not in this orientation. In other words, it's a rotated square function, or reflected, depending on how you want to think about it. I think actually reflected might be better. I think it's actually reflected. So this is a parabola. This is y equals x squared here. And this is half of that same curve. If I was to mirror that curve over the line y equals x, that goes through both of these points, if I was to flip it over that curve, they would match up perfectly. Right? And you can tell we've got 4, 2 here, and this is 2, 4. Or this is 2, 4, and this is 4, 2. So the parabola and the square root function mirror each other. And we can see that even more clearly if I do this other line. So these two go together, right? It's a sideways parabola. It opens to the right, and we can transform this the square root functions to match if we really wanted to. But we could also go open to the left, right? And that would look like put a negative in front of these, and then it opens the other way. We're not going to talk about those function transformations specifically, but we are going to try to graph other versions of these. square roots. So again, this is the square root function. Take everything, all that extra stuff away. This is the square root function. It's always positive unless we transform it. It starts at 0, 0 and goes on for infinity. It doesn't get very tall. I mean, if it's infinite, it's going to be infinitely tall. But it increases slowly, right? It's kind of this smooth curve instead of being very steep and increasing. And it matches with the square root function. Okay. So what about domain and range? When we're looking at this graph, there's a bunch of parts of the graph where there's no curve. There's nothing down here, and there's nothing over here. Okay. So when we're talking about domain and range, we just want to describe where could the graph possibly be, and there are some places that it cannot be. And so domain and range just describes those places. The domain is going to be all the inputs, which is just what could the x values be? What could x be? Well, in this case, x cannot be negative for this one, right? X can't be negative. If I put in a negative, I get an imaginary number, and we're just dealing with the reals. So, whoops. X can't be negative. It's not going to be over here on the left. It starts at 0, and it goes up. And that's it. So x can't be negative. So I need to describe that in terms that are mathematical writing, right? We're not just going to say x can't be negative. We need to say x has to be greater than or equal to 0. This is the domain. And this is how we would write it too. D colon x has to be bigger than or equal to 0. Okay, so that's the domain. The range is all the outputs. It's all the y values. And if we look at our graph, we have the same issue. Because we're looking at square roots and we can't put negatives into square roots, it's never going to be down here. It's never going to be negative. So it's only the positive y values. So in the same vein, in the same way, the range is going to be y is greater than or equal to 0 again. And that's it. Yeah, Sarah, sorry. Where did I start going too fast? Just this domain and range part? Yeah. So the domain you can think of like a king standing in his castle and he looks at his domain, because that's kind of a word that actually means space too. The domain is the stuff you own. Your domain. It's where you go. Um, the thing you rule, possibly. That's a version of the definition of domain. So a king standing in his castle, he can look out at his domain, all the places he can go. Out, right? And then the range, which in this case makes the metaphor breaks down a little bit. The range would be like up into the air. How high can he go up into the air? Well, for graphs, the domain is just how far out can you go left or right? And how far up and down can you go? And so your answer for these, this is the answer. This part. This is the part that you would put on a problem. And it depends. So we're going to do some examples. Ooh, we got 23 minutes, so hopefully we have time. We need time. Where it's not 0. It's not always going to be 0 for these, because we can transform this graph. This can get moved around, right? I can actually move this left. That's fair. That's going to happen. So sometimes the domain's going to start at a different number than 0, but whenever it's a square root, it's always going to be greater than or equal to. right? Because we're going to start at a point, and it's only going to get bigger from there. Or it might get smaller. It might be flipped around or something. But the domain is just what numbers could I put in for x? If I put in negative numbers for x, I'm going to get imaginary numbers. They don't show up on the graph. That's why there's this blank space over here. It's all the imaginary numbers. And so we only want the reals, so it's going to be greater than 0 because we're not putting in negative numbers. For the range, we're not going to, if we don't put in negative numbers, we're not going to get negative numbers out. It's just positive numbers. Y is also positive. So y is also bigger than 0. And when we look at the graph, it should describe where this graph is. I can put in any point over here, any value this way, and I'm going to get values going up. I'm not going to get negative values, and I'm not going to put in negative values. For the square root function, this one's going to be different. We're going to do the cube root in a second. Okay. This might be the hardest part of this, just because we haven't done a lot of domain and range. But you're basically just listing where is the graph? Where is the graph? Okay. So now let's look at the cube root function, the parent function. We're going to do all the same steps, except all of these we're going to need a calculator, except for 0 when we're making our table. Okay, none of them are going to square root nicely. The first number that's going to go into this cube root and look good is going to be 8, because the cube root of 8 is 2. So all the other numbers, well, 0 and 8, right? All the other numbers in between those, 1 through 7, decimals. So our graph is not going to be perfect. We're not super concerned about it being exactly perfect, but we do want to get close. And we'll check in on Desmos, right? We're going to type it into Desmos and see what the cube root function looks like. So the first one here, the cube root of 0 is 0. That's the one that's fine. Oh, and the 1s will also be fine. Keep forgetting. 1's easy too. Cube root of 1, 1, because 1 times 1 times 1 is 1. And then this one's also negative 1. So the difference here with this is we have negative numbers. We're going to get negative numbers. We can put negative numbers in, we'll get negative numbers out. If you remember back before Thanksgiving, we said if we have an odd root here, we can get negative numbers. It's okay. If you have an even root, like a 2, you're going to get imaginary numbers if you do negatives. But with the odd root functions, if you multiply 3 negatives together, you get a negative, so this works. Okay. And so then the only thing we need to calculate is going to be the cube root of 2. And these numbers mirror each other, except that this side's negative. So we only really need to do the cube root of 2. And then we can put that same thing up here. So cube root of negative 2. So we'll need a calculator. And yeah, let me know if I'm going too fast with this section too. Go back to Desmos. Oh, back to Desmos. This is my old stuff. We're not worried about that. We just want to know what the cube root is. So I think the easiest way, I mean, you can go and find the cube root function, or you could do 2 to the 1 over 3. Or you do the cube root of 2. So 1.259. Really, that the third decimal there isn't going to do anything because graphing by hand. So 1.25. And then negative 1.25 as well. So if we're looking at our paper, it's 1.25 and then also negative 1.25. It's mirrored, except this side's negative. Okay. mirrored except negative. So then we're just going to graph those points. The middle three are easy. Always start with 0. And then we'll figure out. So this is going to go both directions here. Actually, I need to move this over. So 0, 0. And then 1, comma 1. So 1, comma 1 and negative 1, negative 1. So right now it just looks like a line, but it is not a line. Okay, and then 2, and then 1 1/4. So 2, and then 1 1/4 puts it about, I don't know, there-ish. So this kind of looks like a fan, the cube root function. We skipped chapter 4, which has x cubed in it, so I will show you how those are related. But this is going to go like this wavy thing. Looks kind of like a fan, or like a old school prop propeller on a plane. A little, not exactly, because those are different mathematically, but it looks kind of like 2 of these put together, but the curves are different. They're not exactly the same. Yeah, the same, right? Yeah, sure. Okay. The cube root function is like this. It's just mirrored, so it goes up this way and down this way. Or not the cube root, the x cubed, the cube function. The cube root one goes to the right and to the left, whereas the x cubed goes up and down. So let's check our work in Desmos. It should look pretty close to that. So I can edit all these things to watch. So this would be x, y equals the cube root of x, and so we get this curve. You'll notice, and mine doesn't look exactly like this because I'm not perfect. We got 1, 1 here, and it's really steep right away. It's really steep right away before it starts curving out. Okay, and so it's different than this square root function. They don't line up. They both go through 1, 1, but you'll see the red and the blue, they don't line up. So they're not the same. And then this is y equals x cubed. And so they're mirrored again. So the blue and the green are mirrored. The cube one gets really big, right? It goes up quickly. It's the green one. And then the cube root one here goes to the right. So this is what we're looking at. This right here. Okay. Now the domain and range for the cube function's really easy. It's really easy. What are all the possible x values? Can I put in negatives and positives? Does it start at a specific point? No, it's anywhere. What about the range? Could I have any y value? If I can put in any x value, can I get any y value out? Yes. Yes. So the domain for this cube root curve is going to be really easy. What are all the inputs? Well, the domain is all real numbers. All of them. Any number. We could put in any number. What about the range? Well, if you put in any real number, the cube root function is going to give you all real numbers. And I want to say this will always be true for the cube root functions. It will always be all reals for the domain range. It's just the square root where there's nothing at parts of the graph. For the cube root, there's always something. Okay. Okay. So we have 12 minutes. I think I have time for 2 examples. I mean, these are basically examples, but the homework problems are going to be slightly more complicated than this. There's going to be other numbers involved. These are just the parent functions. Remember we said at the beginning of the year that we have all these parent functions, we transform them to make other shapes, other curves. Well, we're going to take these parent functions and we're going to change them to be all sorts of other stuff. Okay, so I need another piece of paper. I'm not going to write every step like I did here. I'm going to do the steps, right? I'm going to make a table. I'm going to plot a graph, make a table, plot a graph, and then talk about the domain range. But I'm not going to write 1, 2, 3 and then label this. I'm just going to do it. Okay. Also, let me know if I'm going too fast, please. So example 1. Graph. Let me find the problem I want to do. Yeah, this one. Y equals 2 times the square root of x minus 5 minus 4. Now, some of these might have a half. This is the same as if I had written y equals x minus 5 to the 1/2 minus 4, right? So we need to remember that our fraction exponents are the same as radicals. Those are the same thing. Those are the same. We're going to do this one because this is what I want it to look like on a test or something. That's why we're doing this. But might look like this in your homework in the textbook. So these are the same. All right, so we've done some things. If to the parent function, if we remember back to transforming parabolas in vertex form or transforming absolute value functions, this works the same way. We have gone 5 to the right, 4 down, and we've doubled the kind of the slope. It's not really slope, but we've doubled the function. Okay, so this should be 5 to the right and 4 down. We'll see, because we're going to make a table, if that's accurate or not, but that's what it should be. Okay, and I'm actually going to start not at 0 in my table. I'm going to start at whatever number makes x minus 5 0. Start where x minus 5 equals 0. Which means I'm going to start at 5. We'll see why I did that in a second when we graph it. But when this is 0, that's the starting point, right? The square root function had a point and then it like curved off from there. Like kind of like a rocket or something. It had a starting point. This is going to be where the starting point is. So if you start at 0, if I put in 0 here, I get a negative number. And so that doesn't work. Right, if I put in 4, I get 4 minus 5, I get negative 1, and so I have an imaginary number. Can't graph the imaginaries with the reals. You could graph imaginaries, but not with the real numbers. So we start at 5 because that's where this inside part ends up being 0. We don't get 0. We're going to get a different number. So 5, 6, 7, 8, 9. We probably don't need 5 points, but I like graphing 5 points for most things. And then we just plug them in. These first two are probably going to give us whole numbers. The rest of these probably going to give us fractions. Or decimals, sorry. Does it make sense why I started with 5? If not, you can start at 0 still. You can start at 0 still. It just might not work out the way you want it to. You're going to get some imaginary numbers until you reach 5 here. So we plug in 5, and we get I'm going to do a bunch of scratch work over here because I'm going to do these by hand. So 5 minus 5 is 0. So 2 square root of 5 minus 5 minus 4. This turns into 0. This is a minus 0 here. So 2 times 0 minus 4 gives us negative 4. Then we plug in 6. And you could use a calculator to do this. This is going to turn into 1, so it's 2 times the square root of 1 minus 4, which is 2 minus 4. Square root of 1 is 1, so it's 2 times 1. And so then I just get negative 2. Now 7 is going to give me a decimal. I need a calculator for sure. 2 square root of 7 minus 5 minus 4. 2 square root of 2 minus 4. So it's 2 times that other number we had. Sorry, my paper. 2 times that other number we had, that 1.4 thing. But honestly, just plug this into a calculator. So I'm going to go to Desmos. And delete all this stuff. We don't need it. We don't need that. We don't need that. It'd be 2 square root of 2 minus 4. So negative 1.17 going on. We don't really need the other numbers. We're going to round it because I'm not accurate enough to graph all those decimal points accurately. Okay. And then 8 is also going to need a calculator. So it would be a 3 here. And so then it's negative 0.53 going on. But when we do 9, we get a 4, so we actually don't need a calculator, but we could type it into here, and you get 0. Okay, so our table looks like this now. So now I'm just going to plot that. This is the starting point, right? So our graph is going to start at 5, negative 4. And that means when I'm doing my coordinate plane, I'm actually going to skew it a little bit. It's going to look like that. So 1, 2, 3, 4, 5, 6, whoop, 6, 7, 8, 9, I guess. Those aren't perfect, but whatever. Okay, so then I plot the points, which were these. So 5 comma negative 4. 1, 2, 3, 4. There's a point. 1, 2, 3, 4, 5. Negative 4. 6 and then negative 2. And then 9 and 0, which was this point. These other two, I mean, really, 7 and negative 1.1, like it's going to be about there, then like there. So curve is going to look like this. And it's going to cross the x-axis, and that's what we got. Okay, so this was shifted from the original, right? Our original is like the square root of x is kind of like this thing, right? And so this was shifted over here, and it's actually stretched too. So not to scale. So then what's the domain and range? The domain is going to be x. Domain is always x. And it starts right here. It's going to be all the numbers to the right of 5. 1, 2, 3, 4, 5. Yep. Oh, I put that kind of in between 4 and 5 accidentally, but not equals. X is bigger than or equal to 5. And then the range, all the possible Y outputs that you might get, is going to be bigger than or equal to -4. So it's that starting point. It's this point tells us what these points are what these values are gonna be. Oh, we have 1 minute. Here's what we're gonna do. I'm gonna record another example. It'll go up on YouTube. And so I'm just gonna keep going. This will be in the video, it'll be kind of weird, but technically class ends. Okay, so I'll take attendance. There'll be a homework assignment that goes out later on this. Okay. And the other example is going to be on a cube root. So yeah, I don't know why we ran out of time. It is what it is. Okay, so technically y'all can leave. You can stick around while I do this last example if you want, or it'll go on YouTube. All right, so we're gonna do y equals cube root of -3x plus 1. So be careful, this plus 1 is outside the cube root there. So we're going to make a table. We're going to do the same thing. This is multiplication, so we're going to keep our table centered around 0. So x and y centered around 0. So -2, -1, 0, 1, and 2. And we're going to get decimals for everything. Because this is a cube root and we're multiplying, we're going to get decimals for everything except for the 0 here. So when we plug in 0 to this, we get 1. It's been shifted up, and then it's being stretched, it's being flipped over and stretched by 3 here. So yeah, 0, 1 is going to be on our graph, and then these other ones just plug into a calculator. Okay, so we would use Desmos for that. That look like this. We need the cube root function. Cube root, and then it's going to be -3 times our number, and then we have to go outside and we're going to add 1. So if we plug in -1 here, we get a positive number, we get 2.44 going on. If we plug in a positive 1, it should be this, nope, not the same number. Oh, we added 1 to it. So this is -0.44. This adding 1 here changes the value. And then if we put a 2, -0.81 going on. And then if we make that a -2, not 23, 2, we get 2.81. Okay, so to find these values, we're going to need to use a calculator. Okay, so then I have my table filled out. So then we just graph it. Go black coordinate plane. So 0, 1 is right here. -1, 2.4 is like right here. And -2, 2.8 is like right there. And then 1, -0.44 is about there. And 2, -0.8 is about there. So we get this curve. And then the domain and range, all reals. And the range also all reals. reals. Okay, so that one's actually easier, I think, because the domain and range are just always all the reals. Okay. So that's graphing square root and cube root functions.